the idea here is that I'm not trying to teach to the test and only test you on whatever we teach. And the thing here is that, you know, there are a wide range of topics in each chapter. It is impossible for me to cover every single topic in each chapter there, yet some of them are important, and therefore nothing substitute the reading of the textbook. And plus, you spend $188 on the textbook, and you better get the most out of it. Read the textbook. Okay, so and we finished chapter 1. Now I need you to log on to Canvas and open up chapter 2 learning objectives. So chapter 1 we have 5 learning objectives, and chapter 2 we also have 5 learning objectives. Each learning objective have homework questions assigned in there. So make sure you start working, finishing up chapter 1, and start working on homework assignment, questions assigned in homework assignment in chapter 2. Okay, so the first learning objective here is that we want to give you a basic review of what is periodic table. How do we categorize different types of atoms and elements, and we use the periodic table. So using the periodic table, we need you to be able to state the symbol, the atomic number, the atomic mass, or atomic weight of an element there, and be able to determine the number of electrons, protons, and neutrons in any given element based on the information you can find in the periodic table there. And also, as we know, many of the elements, atoms of many elements there, they belong to the same family, but they may have different numbers of neutrons, and as a result, we introduce the term isotope. So we need you to be able to, that's another D word, define isotope and explain how isotopes of an element differ from each other. And then lastly, the first learning objective there is that define the term ion. What is an ion? So it has something to do with when you see the term ion, it has something to do with electrical charges. So we need you to know how we define ion and how do we figure out the number of protons, electrons, and neutrons in an ion or a neutral element, in an ion of any elements there. So we also introduce what we call a polyatomic ions there. So when we get to the ion part, we'll say some of the ions only have one type of elements in there. Some of the ions you will have more than 1, 2, or 3 different types of elements involved in there, and they bear an electrical charge there. So the first learning objective is to give you a periodic table, and so that when you look at the periodic table, you can look at, you can determine, you will be able to identify the symbol of an element, be able to understand what is the atomic number, what's the relationship between the atomic number of protons, number of electrons, number of neutrons in there. Okay, so looking at the subatomic particles, we say elements, the atoms are the smallest building block of any matter, so meaning you cannot split atoms by chemical methods, and you can split atoms by nuclear reactions there, but there are subatomic particles there, just so you wonder what these are, and that's Chinese for atoms. Okay, so there are 3 subatomic particles there, and namely they are protons, neutrons, and their electrons there. Now, protons have a positive charge, neutrons bears no charge, and electron bears a negative charge. Okay, so those are the 3 subatomic particles. Do we have smaller particles than those basic particles? Yes, the answer is yes. Modern chemistry and physics have discovered there are even smaller particles that makes up protons, neutrons, and electrons there. And but for the scope of this particular course, we just need to know these are the 3 basic subatomic particles that makes up the atom. Any atom is made up of the protons, neutrons, and electrons. Okay, they simply have different numbers of protons, neutrons, and electrons there. So what's the relationship among those 3 different particles there? And we say neutrons have no charge, and protons bear a positive charge there. Neutrons and protons will stay together, and they stay in the center of an atom. Electrons bear negative charge, and electrons will circulate around the positively charged center. So this is what we call nucleus. Okay? And then the electrons are circulating around. Using helium as an example, if you look at helium in the periodic table, the atomic number is 2. The atomic mass is 4. You have 2 protons, you have 2 neutrons, and those 4 particles cluster together. That's a nucleus. Okay, and then there are 2 electrons there. Now, protons bear positive charge, so you have 2 positive charges, and the electrons bear 2 negative charge, so you have 2 negative charge. So in a sense, an atom is charge neutral. You have equal number of protons and neutrons, equal number of positive charge and negative charge within any atoms of any elements there. Okay, so this is how we propose. That's the basic structure of an atom there. You have a positively charged center, and then you have electrons circulating around the positively charged center. Okay, now the relative size and in terms of the size, when we talk about the size there, we're also talking about the mass. How much do they weigh, and how big are they? So we want to take a look at the relative size of those 3 different types of particles there. Now, the diameter of an atom, when we were talking about the scientific notation there, the typical size of an atom there is somewhere around 1.1 angstrom. Okay, so that is about 1.1 times 10 to the negative 10 meter. Remember the unit that we measure, we use in measuring the length. Okay, so that's the standard unit, international standard unit for the length measurement, and they meter. So 10 to the negative 10, and we have another term there, we call it angstrom. And when you see the term angstrom, that represents 10 raised to the negative 10 meter. So that's a very small size. You may ask the question, how do you measure this particular size? How do you measure the diameter? Well, these numbers are not experimentally measured. Rather, we can collect a huge number of atoms there and measure the size together, and then we can divide the total number, divide that size by the total number of atoms there, and we come up with this number there. So the number is not, this number is not obtained by measurement. It's actually based on the calculation there. Okay, so the approximate diameter of the nucleus compared to the size of the atom there is 1 times 10 to the negative 14 to negative 15 meter. So you can say the size of the atom is about 10,000 times bigger than the size of the nucleus. So what can you conclude based on that? Well, the size of the atom is much bigger compared to the size of the nucleus there. And when we talk about the size of the electrons, those particles there, and the size of the electrons versus the mass of the electron versus the mass of the nucleus, the protons and neutrons there, you will see that most of the masses of an atom rest on the positively charged center on the nucleus there. So in this case, by looking at the size there, we can conclude that most of the space within an atom is empty. There's nothing in there in terms of mass there. So that's the relative size of those 3 different types of particles there. And we know nucleus are composed of protons and neutrons there. Okay, so they stay together, and the protons bear positive charge there. So we say that 99.97% of the atom's mass is in the nucleus, and based on that, we say most of the space within an atom is just empty space, and electrons are circulating around the positively charged center, but the mass of the electrons are much, much, much smaller than the mass of the protons and neutrons there. Okay, so that's the basic structure of the atom there. And talking about the mass there, and you're talking about the diameter, and now we're focusing on the mass there. Now, an electron